Um, our project number 7 was on Benthic habitat mapping using the Irish National Seabed Mapping data. And the team consisted of myself and Alison, who's based in Australia, with some contributions from Min Fan as well. And our project mentor was Valentina. Um, the key motivations for this project was to integrate sediment dynamics into habitat mapping approaches. So sediment dynamics provides vital insights into the role of oceanographic forcing factors on the habitat distribution and is so uh, looking at so this work was essentially building on previous work which integrated sediment mobility into habitat mapping approaches. So the main habitat in Galway Bay, which I was studying, was marl or rhodolith beds. So marl forms biogenic gravel beaches and intertidal and subtidal beds in Galway Bay. So it's a type of coralline red algae, and it, in terms of the seabed mapping program in Ireland, there is a very large civilian seabed mapping program going on known as the Infomar program, and the multi-beam. So my goal for this project was to utilize the process multi-beam and backscatter data from the Irish seabed mapping program and for habitat mapping in Galway Bay. So some of the workflow was heavily dependent on ArcGIS. So the goal of the week was to adapt the workflow to transfer it from ArcGIS to Python and run machine learning models to classify the seafloor into geological classes. We had quite some difficulties with the large scale of the data. So we resampled and subsampled and reprojected it in QGIS and then in Python, and managed to open the data as well. And then the backscatter data, which gives an indication of the seabed composition. So the indicates that there are two groups of sediment types. I mean, there are more classes, but based on the backscatter histogram, that the limestone outcrops with gravel and soft sediments with sand mud mixtures with various fractions. This we managed to get the dataset ready for scikit-learn using the train test split to train the machine learning model with labels for supervised classification. This is I'm a beginner in Python, so the maps included from ArcGIS show show the the results of the train test split, which which show which show that 75% of the samples are used for training and 25% for the test. Yep. And so on this just shows the distribution of the gravel, like the gravel areas of limestone outcrop on the limestone outcrops, and also the moa habitats. And whereas more sand mud mixtures are found in the north of the bay. So the support vector machine classification on the was utilized and classifying into numerous classes, and a confusion matrix was 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 obtained, showing that the specificity of gravel was significantly higher than the of sand and mud mixtures. So and then I also have a song as well, so I can play that. Sorry, yeah, I kind of ran out of time, so.
Yeah. Maybe you might have to share the audio on your control bar. There's like a share computer sound.
Okay, and that's all that I have. I'd like to acknowledge the previous co-authors, and thanks for listening. Yeah.
Thank you. Do we have any questions?
We want to try the song again.
Yeah.
Let's do that.
Okay. Yeah. Oh yes, share sound, of course. Yeah. Okay.
In the deepest sea, the colors come to me, diving in your tide, everywhere to hide. In the deepest blue, there's nothing else to do. I've got to find a way to make it through this day, searching, reaching, yearning, not fighting. I have to find a way, come what may. Give me light, give me.
Yeah. Yep, that's the. I can post the song on the GitHub as well. So if I can find a way how to do it. So thank you.
Yes, thank you again. So we'll move on to the next one, which is mooring processing. And what data page